Hey folks, Quilly18 here, and welcome to another Unity program tutorial on our base building game, Project Porcupine. And today we're going to start tackling the very hairy problem of saving game data. This is really hairy because there are many different solutions to saving and loading data, and all of them are more well suited to slightly different versions of the problem. There's not really a one-size-fits-all solution, and it really depends on how your data is structured and what it means to save and load. What are you saving and loading? How complex is your thing? In this case, we are going to be saving and loading entire world data, which is a considerably different problem than what happens in a lot of situations. So we have a lot more data to save, and they're linked and interlinked in very different ways than a lot of programs, might deal with. The very first thing we have to deal with is the idea, first of all, that we are going to discard our current world and load in a new world. That's like step one is actually that. Before we actually even get to the saving and loading, right now, when we hit play, we create a new world object and a bunch of tiles that are set to the default empty tile, and we create a character and we set up a job queue and we do all these things. And those things all exist in memory, and then sometimes we end up with, some world information around, and we end up with some things in our queue here. And to load a new level, or even to load a new game, what does that mean? And actually, that's the very first thing we're going to deal with is, what if we want to restart the game at this point? Well, obviously, we just hit stop, and then we hit play again. Right? That's fine, but obviously it's not that great. We don't have to force the player to quit out completely. So the first thing we're going to do is put in a button to reset the world or to create a new world. And that's already going to approach certain topics that we need to discuss. So we're going to make some new buttons over here in our canvas. We've got our pathfinding test button. I'm just going to duplicate it. And let's actually take the real one over here, which is over here. And I'm going to move it to the top right corner. You go over there. So that's the real pathfinding button. And this one over here is going to be our new world button. Like that. I'm going to change it to just like the white background is fine. And we're going to update the text right over here. Okay. There we go. So we got new world over here. So what I want is when I click this button, I want our current world to be thrown away. I want everything to be reset and to come back to our initial sort of settings. The same thing that you get when you start the program fresh over here. I want exactly the same thing to happen. So where would we do this? Well, first of all, the pathfinding test button runs a function on build mode controller. And honestly, maybe that should have been pointing somewhere else. It's a moot point though, because that's not going to stick around forever. But I think it makes sense for our new world, and in fact later on our save world and load world button, to do something with the world controller. I think that conceptually makes a lot of sense. So we're going to open up our world controller over here, and we're going to take a look at it. Yes, no, there we go. Embiggen. All right. So how does new world controller work right now? Well, when it gets enabled, which is what happens at program start, it creates a new instance of the world. So it does this stuff. It just makes sure that our program knows what the current instance of the world controller is and all that. And that's fine. That can still be on enable. But then over here, it creates a world with empty tiles, and then it centers the camera based on the world's width and height. All right, that's fine. Let's go and let's move this out into another function, though. It's going to be step one of cleaning this up. Let's cut this out. Let's create a function over here. We'll make it a public. No, not a public. It's going to be fine. A void called empty world. Create empty world, create empty world. I like functions to have like a verb. So create empty world is going to be that. And so we can go back over here on enable, create empty world. That's great. But then we also want a button. We want a function to handle our button. This does have to be public void, and this is the new world button, right? So over here on our button, we will make sure that we are pointing to our world controller object. And in there, we're going to grab the world controller script and the new world function. There we go. So now when we click on this button, the new world function will get called, and we can put in, I don't know, debug.log, like that. So we confirm that that button will get clicked. Okay. So now comes to the first issue. If we want to create a new world, what would happen at this point if all we did when we clicked the new world button, what if we just ran create empty world? What would that do? Well, I can tell you it definitely won't do what we want. Let's actually not maximize here so that we can see the error log. I don't think it'll create an error, though. We're going to hit pathfinding test again just to give us some stuff in the environment, and we'll go and queue up that, and I'm going to hit new world. And you don't see anything happening. Why is that? Well, new world is definitely executing, and we are in fact creating a new world with 10,000 tiles. The problem is that all of the visual bits over here are still pointing to the old world, and we haven't actually destroyed the old world at this point. C# is a managed memory environment, which means you never have to manually delete something that gets instantiated, okay? If we're working in C or C++, or actually many other languages, when we create a new object like this, at some point we would have to destroy it or delete it or something. Languages have slightly different syntax for it, but presumably there could be something like delete world that would tell your program to uninstantiate this memory. Now, what would happen is if we still had a reference to this world, this old world somewhere else, some other variable, somewhere else we had, hey, world 2, or, world other var is equal to world. If we do this, we delete world. Well, this is still trying to point to some area of memory, and that's when you get program crashes and horrible things happen. Now, this isn't actually an option in C# at all, because there's no way to explicitly delete a world. The closest we get is if we say something like world equals null. Right, at this point, this variable, this right here, is no longer pointing to our instance of the new world. And if this was the only thing that was pointing to this new world, the garbage collector at this point would go and clean that up. Now, if we still had world other var equals world, if we still had that, this would still be pointing to this. So even setting this to null doesn't clear this up, but this would no longer generate an error. It would just be pointing to the wrong world, a world we don't want things pointing to anymore. So one thing we could do is track down everywhere where we are pointing to that world and null them all. There may be a few places in our program I know for sure that are tiles. Our tiles keep a reference to the world. Right here. Not only that, but the world has a reference to a tile, so it's somewhat circular. But that's okay. Okay, so tiles have a reference to a world. So we could go and clear these all out. But the other thing is, if nothing references these tiles anymore, then they will also get garbage collected. Now, the world points to the tiles point to the world, but that's okay. As long as nothing outside of that loop points to either the tiles or the world, eventually it will get garbage collected. So, I mean, there's two things here. One, we don't want anything to be pointing to the old world data anymore, because we don't want to accidentally be doing stuff on the old world when we have a new world that is shiny and new that we want to work with. That's one thing. But the other thing is we want to make sure it gets garbage collected to free up RAM. So that way, the longer you run your program, you don't keep using it more and more memory until you just restart the program. That would be very bad. So as long as nothing is pointing to either the world or the tiles or the furniture, which furniture has a reference to tiles and so on and so forth, we'll be okay. What else could be pointing to it, to this data? Well, right now, and I think this would not run because, oh no, it would actually run, technically. Oh no, it wouldn't actually, because that world null, that would be bad. There you go. If we hit if we hit pathfinding test, so we've got all these tiles. Hey, keep breaking it. I'm trying to demonstrate something. We have all these tiles, these sprites, right? Our tile sprites. They don't point to the tile, but our tile sprite controller does. We have this dictionary here, which keeps these old tiles in memory. And there's a bunch of stuff like that that are pointing to this data. How do we make sure that all references to it are wiped out? The easiest way to do that is for us to just reload the scene. So we have our data model objects that exist, and we have our Unity game objects that exist. As far as I know, the only if we were, I'm pretty confident about this. If we were to reload our scene, or imagine this. So we have all these various controllers and things like this that have references to the world or to the tiles or so on and so forth. If we went and deleted all these when the program was running, that would eliminate all references. If we deleted this, which would also delete all of our sprites, right, which exist underneath our tile sprite controller, if we deleted all these, there would be nothing left referencing the world or the titles. The garbage collection system would eliminate all that stuff immediately. Well, we could delete all those and recreate them. The easiest way to do that is to reload our scene. if we reload our scene, then all our old controllers will be gone. There'll be nothing left pointing to our old data. Therefore, A, we know for sure everything is going to be pointing to the new world, and B, all the old world stuff should get garbage collected on the next pass. So we can test for that later on, but let's hope that works. So what we need, if we want to be able to change scenes as of Unity 5, I think this is changed in 5, we need to make sure to say that we're using the scene management library. Wow, we don't need to use this. We could just type more later on, but that would be stupid. And when we hit this new world, this is when we create the new world again. Or this is what happens when the button, new world button was clicked. Rather than create an empty world at this point, let's just reload the scene. So we go scene management dot, scene manager dot load scene, and we have to give it a scene name specifically, or an int. Okay, a name or the integer index of the scene. We can get the name of the current scene very easily. We can go scene manager dot get active scene. This returns a scene object which has a name, and we can do this. So this will just reload whatever scene we're in, which will destroy all of our game objects, which will eliminate any references to our data models that are sitting in memory, which should cause them to be garbage collected. And then we get a whole new, when the scene loads again, we get a whole new scene, a set of controllers, which will point to a completely fresh set of data. So let's give that a go. We're gonna hit play. Pathfinding test, we've got this. Let's hit new world. Boom. This has reloaded our scene. Same as if we'd restarted the program. Everything is blanked. And again, we'll check memory stuff later on to make sure that we're not getting any memory leaks, but we should be good to go. I can go and set up some jobs over here. And again, hit new world. Pathfinding test. No jobs as far as I know. And if I click build wall and click over here, everything should be hunky-dory. So that's the first step. And I mean, the new world button is good. We want that. Now, we also want another button. Public void, well, we want two more. Save world and public void load world. Now, later on, we're going to want save world to, I don't know, ask you for a file name to save it in a folder, and then we want load world to open up a list of all the files that are saved in a particular folder and let you pick one and load it. For now, for initial pass, we're just going to have one save game, load game slot. That way we don't have to worry about file system stuff. It'll also work fine in a web player, because the web player can't access the file system, but it can access user prefs, which is the Unity per application set of file data, and that'll be a fine place to store one instance of our save game. But let's go and our new world button over here. Let's go and duplicate. And should we put this in like a little horizontal thing? Actually, let's do that. Create empty. I don't know, top menu. Obviously, the UI is going to get remade later on. We're going to take, you know what, let's take all these buttons, throw them in top menu. Let's give it a horizontal layout group. Perfect. We want you to be across the top of the screen. Height, I don't know, less. That much. Actually, we don't want full width. We want you to be in the top left corner. And then we want to do something like that. Let's move the pathfinding test maybe to the end. All right, I like it. And rename these buttons. So this is going to be load world. I guess that's fine. Actually, we'll just call it, we'll just label the button as load. Oh, and I forgot to hit enter. Of course I did. Load, enter. And over here, save, enter. And save. Okay, that's all done. Good. We have to make sure these are running the correct functions. Load world and save world. Okay, so save world, we're going to come back to it. Let's do debug.log, save world, and load world. You know, saving it is going to be a to-do. Load world, we're going to want to do the same thing as with new world, as in we're going to want to reload the scene. Reload the scene to reset all data and purge old references. We're going to do that, but what's going to happen when the scene reloads? Rather, So when the scene reloads and on enable runs, rather than create an empty world, instead of creating an empty world, we actually want to load a world from memory, which is going to be slightly different. So how are we going to do that? Well, there's a bunch of different ways. I'm going to take a very easy approach right now. We'll probably change it later. I'm just going to set a little boolean here, which is going to be called load world sets to false by default. Okay? So we're going to have another function here. Create empty world is going to create world from save file or something like that. All right? Different version of this. Right now they're going to do exactly the same thing. That's fine. And so over here, if load world, then we are going to run that, and otherwise we are going to run this. Now, there's one problem here. If we write load world like this, it's going to belong to part of our object. It's part of our world controller instance. The world controller instance gets reset when we reload the scene. So instead of being a member variable or property like this, we're going to have it be a static. This way it will belong to the class. And reloading a scene will not, when we recreate this object, it's not going to reset this. This only gets set once at program load. So it's sort of a global kind of parameter. So by doing that, what we can do is when we say load world, hey, before you load the scene, say that, yes, we're going to want to load the world. Later on, we'll probably have this be a string that asks for a file name or something like that, or we might change the system completely. But we're going to set the load world to be equal to true. And then over here, after we've loaded the world, we're going to set it to false. So now it'll create the world from the save file, and we can verify that this is being run right over here. So it's still going to create just an empty world for now. But we have a certain amount of structure in place. So we can do pathfinding test, and I can say, oh, you know what, I would like to load the world. There we go. And it says create world from save file. Right now it's just creating an empty world, but that's fine. So now we get to the fun part where we actually save and load data. So how are we going to do that? Okay. It actually generated a giant text file about stuff to talk about and issues that I want to bring up and what my decisions are going to be here for our particular configuration. I guess I can still go through it real quick to talk about my plan. So here's my first requirement. Is I require, for our purposes, and I think this is in general a very good idea, that the save data must be in a human readable format. Okay, which means some sort of XML or JSON or something like that, like some sort of text-based format. Whereas any person can open up the file in Notepad or something like that and see the saved data in there and have it, vaguely make sense. That will make it much easier to debug. It'll make it much easier for other people to develop, tools or mods or something like that. Security, who cares about that? Yeah, people could go and change the data and cheat. But why do we care that much? It turns out it's really not an issue that matters in any way whatsoever. If we are worried about that, as well as if we were worried about the file size, because this will be a relatively large file, this will compress very well and be relatively small. And when you zip a file, you can password protect it. So there's possibilities over there, but it's really sort of a moot thing. We may do some compression later on, but for now we're just going to save the save files uncompressed. This is actually a very common approach that's becoming more and more common, rather, with a lot of different applications, including like word processing systems. I think Microsoft Word does this now. Certainly LibreOffice or OpenOffice or whatever you want to call it does that. Like the save files for that are basically just a zip. You can literally just rename it to a .zip and open it in 7-zip or something like that, and you can see a variety of files that are in there, and a lot of it is actually XML format stuff. And it's actually a great format because it's easy to save corrupted files. It's easy to convert from one format to another, and it's future-proof in that anyone later on, even when your program is dead, will be able to open the save file and be like, oh, we can work with this. We can get this data out of here because it's not in a weird binary format that is just not human legible. So it's going to be that. Now, ideally, the other thing I would like is to minimize the amount of special code we need to enable saving and loading. Because this would require us to constantly change the save system as we add, remove, change data structures, right? So if we add some new trait to furniture or something like that, right? Like, I don't know, it's temperature, then that's a new piece of data. And if we constantly have to go and update the saving and loading system to be able to deal with this extra piece of data, that's annoying. The problem is that unless we are literally saving data on objects where on the object all of the properties that we care about saving are, say, public, okay, if we're doing XML saving. But the default XML serializer in C# will automatically serialize all public info. Yeah, there's two problems with that. Some of the stuff we want to serialize might be private or protected, which the XML serializer will not do by default. And the other thing is, some of the stuff that's public, setting it and getting it directly, I mean, it goes through a certain amount of massaging, and it calls callbacks and different things like that, and may not be the sort of thing we necessarily want to run when we're saving and loading. So we're sort of picking and choosing, right? We're using certain convenience, some setters to update values more conveniently, but it can cause problems with the serialization process. And part of the problem too is that the built-in serialization tools, they don't all work the same way, which kind of annoys me as sort of a purist. It would be nice to just sort of define, what data should get saved once, and then I don't care if it gets saved out to binary or XML or JSON or some other format, it should just work, period. And that's not the case. So for example, the built-in C# binary serialization also serializes private data, not just public. The XML version requires you to have a parameterless constructor, whereas the binary one doesn't. And this means you do have a public parameterless constructor available, which means it's possible to construct a new instance of an object without passing it any parameters, which you may or may not want in your actual code. You might not want someone to make a mistake and accidentally call that. Maybe it doesn't matter, I don't know. But it leads to wonkiness, and it's really annoying that it's inconsistent. And yeah, so in practice, what I have decided to do, sort of split the difference. And again, there's a lot of different approaches here that are very, 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 very valid. We are going to go with XML serialization. Serializing and deserializing just means saving and loading. It's basically talking about taking your object data and converting it into a format that's suitable to put into a file. We're going to use XML. So that way we don't have to use any third-party libraries. The JSON library, JSON.net, is excellent, but it is a third-party thing. It's open source, but yeah, we'll just use the XML. It's going to be fine. And we're going to use the iXML serializable interface and write custom reading and writing code, okay, or saving and loading code for our objects where we need it, so we can massage it. Maybe some objects won't need it, and we'll just be able to do a default serialization with XML. That'll be great. But luckily, we don't have that many different object types. We've got tiles, characters, furnitures, jobs. And honestly, that might be it, so it might not be that painful to write our own code over there. Plus, some people will be able to use this information to, do their own programs where they need something more customized. So there we go. So there's some of that stuff. Yeah, not all the links between objects might get recreated in the way we want if we just use the default ones, yada, yada, yada. Reinventing the wheel sucks, but I think we do have to customize things a little bit, no matter how much we want to avoid it. So, and it'll be a good learning experience. So, okay, world controller. Obviously, we want to start with saving before loading. So what is this going to look like? We don't need the tile. We don't need the tile sprite controller right now. What we need to do is go into our world controller. And we are going to implement, sorry, not world controller, into our world. Okay, so the first thing we're going to do is, okay, actually, we can go to our world controller. Hold on, let me back up over here. In our save world, we're going to start the saving process at this point. And let me make sure I've got the right window open just so I get the syntax correctly. What we're going to do is we are going to serialize our world data into an XML text, right? XML is just text. We could save it to a file, but we're actually just going to save it to a string, and then we can output the string in our debug log, which will be nice to see. And then we can also save the string into a user pref. And that's one of the things we're going to do. So what we need a few things to include, I believe. Well, let's start writing it, and then we'll be able to auto-resolve, because we're going to add some stuff over here in using. And I just don't remember off the top of my head what they're going to be. But we are going to use, so we're going to need something that writes text. We need a serializer first, actually. Let's start with that. We're going to need an instance of XML serializer, and we can call this serializer. That's great. Serializer. Think that's spelled correctly. And it's red, though, because we haven't included the correct library. There we go. And you can, in MonoDevelop, you can right-click on something, resolve, and it'll add the correct using at the top. So you can say using system.xml.serialization. So that's what we need to include to be able to use that class. And we'll call this serializer. Sure, it's a bit verbose, but, you know, again, I like it. And we're going to create a new instance of XML serializer. It requires a type. Well, I mean, we're going to require a few different things, but we're going to use basically this version where it just needs a type of object, the class name basically, to serialize. So we're just going to say type of. So you're going to be serializing a world. That is the type of serializer you're going to be. Done. Then we're going to need somewhere to write this. So this is the thing that's responsible for turning an object into basically into XML, but it's going to need to write that somewhere. It's going to need to dump that somewhere. So it's going to need for us, we're going to use a text writer. So text writer is actually an abstract class that is just meant to work with text. The text writer by itself doesn't know what kind of, where the text is actually ultimately going to be saved. And there's a few different variants. If we went with stream writer, which I think would require including something like system.io, this would be writing to a file. You'd actually have to specify some sort of file name. You know, foo.xml. Extension doesn't matter. You can call it whatever you want, but something like that. We're not going to use that. Instead, we're just going to write directly to a string in memory. String writer is, I think, what it's called. And then if we right-click and resolve system.io. Is this all system.io? Okay, there we go. And if I got rid of this and went stream writer, yeah, it's in there too. Okay. There we go. String writer. So this is just going to write to a string in memory, which is fine. We don't have that much, and it's going to be convenient, and it'll be great. Okay, so we got that. And then what we just say is we say, listen, our serializer, you are going to serialize. You are going to send your data to our text writer. And what are you serializing? You're serializing our world. And then I think, even though it's not a stream, we still have to close the writer. And then, because it's just a string, we, I believe, can do debug.log, and we can just get the actual string data from the writer by going to string. I think this will generate XML and do that. Now, I'm quite curious, if we did nothing else, what would this spit out, actually? Let's find out. Are we getting any errors? Just clear the log here. No. Let's hit play. And hit save. Aha! Excellent. Well, excellent-ish. World cannot be serialized because it does not have a default public constructor. So our world only has one constructor, and it is over here. But it is not a default constructor because it has parameters. Even though we actually offer in some default data over here, this is still not a parameterless constructor, a default constructor. And serializing XML requires that. Again, what does it mean to create... Let's go to the bottom. Let's go to the bottom and create like a room like this. We'll make a section for saving and loading code. Nope, I'm good. No more of those. Thank you. All right. So we need a constructor for world that is default. I wonder, do you have to make it public? If I made this say protected, not void. There's no return type. If I went protected world, would that satisfy it? Now it's worth noting we didn't get a syntax error. It's not a compile time error. It's a runtime error. It's only when we hit save that it'll let us know. Yeah, okay, it does have to be public. All right, that's what I thought. So now it has a default public constructor. Right now this doesn't do anything. Calling this version of the world would actually be dumb because, well, it doesn't instantiate anything, right? This constructor over here sets up job queues, takes in the height and width and all those things. But we've got a dummy one right now, and that should satisfy ambiguous call. Oh, there's an ambiguous call because, when we create our empty world, we're just saying new world, and it can't tell if we want this constructor or if we want this constructor, because this has default parameters. I'm going to go ahead, I'm going to remove these default parameters. And now if we were to run it, it would create the world that doesn't have anything. We would definitely get an error right now, because when it's trying to create an empty world on start, you see all these errors? It's because it's running the default constructor, which does nothing and is the dumb one. That's one of my concerns with the with this approach, is it does give us the opportunity to kind of F up and use the wrong constructor. That being said, we're really only ever going to call the world constructor in one place. You know, we'll just have to make sure we're using the right one. I guess it's probably fine. So now we should be back at the place by specifying which constructor and putting in the 100 by 100. We once again get a new world. Pathfinding test, good. And if I hit save, now it's got a different error. Actually, maybe it had run this error before, but I don't think so. It's now complaining that path tile graph can't be serialized because it doesn't have a default public constructor. So what's going on here? Why are we not getting an error about the world? Well, as I said, the default XML serializer, where's it? Oh, it's save world right here, right? Our XML serializer, which is being told to serialize the world, it's going to go and look at all of our public properties on world and try to serialize all those things too. Our tile graph over here is public, which means it's going to try to serialize it. I'm not sure if XML serializer would obey the non-serialized for this. It may not. That could be one solution. And again, we can sort of manually set all these things. But what we're going to do instead of having the XML serializer try to do its best job of serializing stuff and making a lot of guesses, instead our world is going to implement XML serializable. So easy to typo on this. It's going to be red because we've got to include some stuff. There we go. I'm going to save a little bit of time. We actually have to include system.xml and system.xml.schema as well. We need to include all those things to make this work. So now if I try to tab out over here, or hit F8, we will get compile time errors because we are saying we are implementing the iXML serializable interface, but we're not actually doing it. It's missing 3 functions: get schema, read XML, write XML. So down in our code over here, we're going to add those 3 functions. Now, what's kind of funny is that the get schema method is reserved and should not be used. You can do some, DTD, the data template document? I don't remember what it stands for in XML, where you sort of define what the XML file is supposed to look like. You can do that sort of thing. We're going to skip past it. So we do need, so we need these 3 functions. We need to supply this public XML schema returning function called getSchema, but it's just going to return null. Really does nothing. The ones that actually do the work is going to be a public void write XML, which gets past an XML writer. So save info here, and we need a public void read XML, which is going to take in an XML reader. Load info here. And I think, we should get, no compile errors. We still got that warning, but that's fine. And if we hit play, our empty world goes and pathfinding test. And if I hit save at this point, I don't think we'll get an error. There we go. And our debug information, because you remember on this line here, so we're instantiating an XML serializer and a text writer, which is just going to write to a string. We're telling the serializer to serialize the world object into that string, and then we're asking the string to just print itself out. And it is giving us this, an XML file, which is literally just an empty XML file. It's got the XML definition tag at the start, XML version 1, which is just required, our encoding rules, that's just automatic, and then it's got one tag in there called world, and it's actually a self-closing tag because there's no data inside of it. But it does call it world, which is the name of our class. There are things that you can do to tune the name that is used for that class by default, but at this point, I'm perfectly happy with that. What kind of data can we write in here? Let's go ahead and put in a quick little bit of data about our world. So what do we know about that we want to write in our world right now? Well, we should add write attributes. Virtual void, is that something we want to use? Not what I was thinking of using. I don't have mastery of this particular library, so there's a lot of little things, but we want to write attribute string. We're going to add an attribute to our world tag. We're going to call the first attribute width, and we're going to pass the data of width. So it would be nice, and again, by default, it would sort of all be automated here if our data structures were simpler. But I don't think there's a good way to simplify our data structure in a way that makes saving less troublesome while still retaining some of the functionality that we're hoping for. I think we're just going to have to suck up to the fact that we're going to kind of have to manually do some of this writing. So let's see what happens if I run this. Stop the program. Oh, I have an actual... Oh, toString. Because this writes string. There's a few other ways to do it. There's also writer dot what is it? Write int. Write value, and then this one comes in string, boolean, integer, etc. But this will do something different. As an example, what I could do is write a value of width and height. Let me also do that, and we can compare the two. But this one will not really do what we're looking for. Hit play. And hit save. And so now, if we look at our data, I know it's a little small on the screen over here. I wonder if there's a way to make that bigger. You can see now our XML file, the world tag has been extended. First of all, it's not a self-closing tag. It's got a start tag, which is here, and an ending tag, which is here. It's got two attributes in it, one width, which is set to 100, and a height, which is set to 100. And then it's got this string inside of our world tag. Between our start and ending tag for world, we've got 100100. What is that? Well, that's this bit. We are writing the value of width and writing the value of height. So clearly that's not the way we'd want to write that. We could instead, so we could use attributes. There's two approaches when you're writing data at XML. Sometimes you'll use an attribute like this. Other times what you do is write start attribute called, call it width, writer dot end attribute or end element. Again, limited amount of experience with this particular library, so some of the syntax. No, that's just creating a new attribute. That's definitely not what I want. So this is another way to write this. It was exactly the same, which is why actually if you look here, we've got width over here and another width over here. So those are exactly the same. That's not the one I'm looking for. It's write start element is the one I want. There we go. Not attribute. And then it needs a string, good. And then write end element. And I don't think it needs to be passed a string. It's smart enough to know. So now if we do that, what we'll have is a nested element inside of our world. There we go. So we have world, which still has its two attributes over here. Again, I realize it's very, very small. I guess what I can do, grab this. Can I just start a new notepad? There we go. New notepad. Paste. Font. Big. Maybe not that big. There we go. You could also have it pop up inside of the Unity app. That might be good. But there you can see. So you can still see our code here is writing the two attributes of width and height. But it also, we have it set up a new element within the world of width. And we could do another one of height. So these are both perfectly legit ways to communicate this data. And it mostly comes down to sort of what kind of logically makes sense, what feels better for the organization. To me, I feel that the width and height makes great sense as an attribute of the world element over here, as opposed to a sub-element within. I think this just feels better. And then our tile info might be something within this, for example, and also all of our furniture and so on. Those could be tags within the world, nested within. And I think that makes a hell of a lot more sense. But they're both perfectly valid ways of doing it, and reading that, reading either one of these versions works pretty much the same. But for the sake of argument, we're going to stick with that. I'm just going to go ahead and comment out this bit. We'll do some things like that soon, and we will also have to read this data. But we have the writing is starting. I got to put a cut in here because we've gone way, way, way too long. The next episode will actually stuff this XML into a user prefs, which, by the way, if you're doing a very simple program that only has to save very simple things, saving directly to the user prefs is probably fine. We're generating an XML file because we want to be able to later on save our data to an actual save file that's, sitting on the hard drive somewhere, and our data is a bit more complex. I think we'll appreciate doing this. Plus, we get a little bit more automation with the XML stuff, even though we are going to have to specify manually which attributes to write and then read from the XML file. But I think we're striking a happy medium between a certain amount of optimization, or a certain amount of automation, but also the amount of customization that we are going to want to really make this work out well. So thanks for watching, folks, and I'll see you next time. Thank you very much to all our January supporters over at patreon.com/Will18Creates and these Mic Check supporters. We've got Alexander Gutler, Andre Odendal, Neil Blakely Milner, Speedy Savant, Valiant Cake Fiend, Aaron Toyson, Marius Field Vold, Disco Geek, Ole Peter Talgo, Julian Auger Lafont, or Auger Lafont, I should say, Steven Stagger, Michael McClintock, Kale the Quick, Drazion, Wes Oldenbeving, Craig Mortel, Nail or Nale, I don't know, Vikstrom, and Andrew Henninger, and everyone who has watched, shared, favorited, and subscribed to these videos, and left comments as well. You guys really keep things going. Thank you very much for watching.